All right, welcome to The Explainer. Today, we're tackling what is, quite possibly, the single most mind-bending, reality-shattering experiment in the entire history of science.
So, you know that old question, right? If a tree falls in a forest and no one is around to hear it, does it make a sound? It feels like one of those deep thoughts you'd have over coffee. A fun little philosophical brain teaser. But what if I told you it's not just philosophy?
Yeah, it turns out physics actually has an answer. And I've got to warn you, it is way, way weirder than you could possibly imagine. The answer suggests that the universe itself, well, it acts differently when we're not looking. I know, that sounds crazy. The only way to really get your head around it is to see the experiment that proved it all.
Okay, so let's dive into the unwatched world. First up, we're going to see what happens in this strange quantum realm when there's nobody watching. No observers, no measurements, just tiny particles left completely on their own.
The setup for this is actually, brilliantly simple. Here's what we're going to do. First, we have a device that can shoot out tiny particles, like electrons, just one at a time. Then, we aim those particles at a wall with two little slits in it. And finally, behind that wall, we've got a screen that will record exactly where each particle lands. That's it, simple.
Now, let's think about this logically. If these particles are just like tiny little marbles, what should happen? Well, some will get blocked by the wall, obviously, and the ones that make it through one of the two slits, they should just pile up on the screen right behind those slits, creating two simple lines. Make sense, right? Totally straightforward. Except, that's not what happens. Not even close. What we actually see is just bizarre. Instead of two nice, neat lines, we get this pattern of many different bands spread out across the screen. This is called an interference pattern. And, well, that's a dead giveaway for something completely different. It's the exact pattern you'd see if waves were passing through the slits, rippling and interfering with each other.
So think about what this means. Even though we are shooting these things out one by one, like little bullets, they're somehow acting like waves. The only possible way to get that interference pattern is if each individual particle isn't really a particle at all, but some kind of wave of possibility. A wave that actually goes through both slits at the exact same time, interferes with itself, and then hits the screen. It's wild.
So yeah, a single thing is somehow in two places at once. Is your brain broken yet? Because mine was the first time I heard this. Let us know what you think is going on down in the comments.
Okay, part 2, the act of watching. So as you can imagine, scientists saw this result and just had to figure it out. They thought, okay, let's just watch and see which slit each particle is actually going through. But that simple act of looking, well, it changed absolutely everything.
So to try and solve this mystery, they just tweaked the experiment a little bit. They put a tiny detector right at the slits. A little device that would just register, yep, this electron went through the left slit, or okay, that one went through the right slit. A simple little measurement. And the moment they did that, the moment they started watching, the whole pattern changed. It was like the universe suddenly got shy and changed its mind. Everything was different. The mystery wasn't solved. Oh no, it got so much deeper. So just to recap, right? When we're not looking, when there's no detector there, the particles act like waves. They create that bizarre, multi-band interference pattern we saw before. But the instant you watch them, the second you put that detector there to see which slit they go through, poof, the interference pattern completely vanishes. The electrons stopped acting like waves and suddenly start behaving like those little marbles we expected all along, leaving just two simple, predictable lines on the screen. So this leads us to the unsettling truth. What on earth does all this mean? Well, it points to a conclusion about reality that is deeply, deeply unsettling. This is the core takeaway, the big mind bender right here. The very act of observing a particle changes its behavior. It's like the universe knows you're watching. The simple act of measuring which path it takes forces it to stop being a wave of possibilities and pick one, collapsing into a single, concrete reality.
This incredible phenomenon has a name. It's called wave-particle duality. And it's basically a cornerstone of all quantum mechanics. What it means is that on the tiniest scales, things don't really have a definite state until you measure them. They just exist as this fuzzy cloud of possibilities, a superposition. And what you end up seeing, well, it literally depends on how you choose to look at it.
So why does this one weird experiment matter so much? This isn't just some abstract thought experiment. It's the absolute bedrock of quantum physics.
This whole idea that reality isn't fixed until we measure it is what makes things like lasers and the microchips in your phone even possible. It's the rule that we're using to build the next generation of technology, like quantum computers. It really forces us to accept a crazy idea. The observer isn't some passive bystander. You are fundamentally part of the experiment.
So, let's go all the way back to that tree in the forest. Does it make a sound? Well, quantum mechanics suggests that until something is there to observe it, the falling tree is just a wave of possibilities. It's a potential sound. The sound as we know it, as a real, definite event, only snaps into existence when a measurement is made, when an eardrum or a microphone is there to collapse that wave. If your mind is blown and you love these huge questions that really challenge what we think of as reality, then you are definitely in the right place. Make sure you subscribe for more.